All right, we got page 89, our composition one, and we were given two functions here, f and g. We were asked to compose them one way and then the other, and then actually do something for f. So we'll start here. When you do a composition, another way of writing this would be like this here, and sometimes it's a little easier to understand. What we're doing is we're taking the g function and putting it inside of the f, all right? So take whatever g is, put that inside of the f. So instead of x cubed, we're going to go 1 over x cubed. See how the actual 1 over x is inside of this, taking the place of that x. And if we want to simplify that, you can just go 1 over x times itself 3 times. You'll get 1 over x cubed if you simplify it like that. Okay? G of f is, again, the same idea. This time we're going to take the f function and we're going to put that into the g. We're going to take x cubed and we're going to put that in for the x here. So that means we'll just simply get 1 over x cubed. Now, it doesn't always work out this way, but you can see that in this case we got the same thing there. Okay? And then f of x means we're going to take the f function, put it right back into itself. We're going to take x cubed and put it into this 4x. So if you kind of think like, here's the f function, x cubed. What's going inside for x is the f function. So here's the inner f of x, x cubed, and then the outer one is this out here. And then when you do this, you multiply. So 3 times 3 would give us x to the 9th. And if you're like, I thought maybe you added, well, an easy way, whenever you get stuck, is just expand, right? The third power means times itself 3 times. So x cubed, x cubed, x cubed, 3, 6, 9 gives us that right there. Now, 38, we're taking these two functions and composing them. So again, f of g of x means we're going to take the g function, put it into the f. We're going to take x to the 6th, put it right in there. We're going to have x to the 6th inside of x to the 2/3. And we're going to multiply. So 6 times 2/3, that's 12/3, which is the same as x to the 4th then. And then g of f of x means we're going to do this similar, except now we'll put f into g. We'll take x to the 2/3 and put that into here. So you're going to have x to the 2/3 raised to the 6th power. And that's also going to give us x to the 4th. So again, don't get in your head that this always ends up being the same. That's not necessarily the case. But in this particular example, we got the same answer both times. All right, 46. Now we're going to do some figuring out based off graphs and this. So it can get a little confusing. If you just follow kind of an order, it works out pretty nicely. So I have here f of g of 1. So what I want to do is figure out, what does g of 1 equal? So I'm going to go to the g function. I'm going to go to 1 and count up, and I can see that g of 1 is this equal to 3. It's at a height or a value of 3. So if g of 1 is 3, then instead of doing f of g of 1, let's do f of 3, because they're the same thing. Now I can go to the f function, I can go over to 3, and that's at a height of 2. So I have to do kind of two different things, right? I have to figure out g of 1 first, get that value, and then use that to figure out the outer value. So we'll do the same thing here. We got g of f of 3. Now, we just found f of 3, right? Based off of this graph, f of 3 is equal to 2. So that means we're going to do g of 2 now. So if I go to 2 and up, that's at a height of 2. All right. Now, the last two problems here want us to look at a composite function and see if we could figure out like what went into what in order to make it. And sometimes this is a little bit, sometimes it's not too bad, especially if you see it. So we're going to do this. We're going to define for this one that f is the outer function and g is the inner function, all right? And because that was kind of what they asked us to do. So I want to know what would be the inner function. If you kind of look at this one, you can see that 9 minus x is inside of the square root, right? So 9 minus x is going to be our inside function, our inner function. And what did 9 minus x go into? It went into square root of x. And this x now is just a placeholder, right? You're putting the 9 minus x inside. That goes away. And we replace it with 9 minus x, and that's what we get there. Okay? So we're trying to just simply look at it and say what went into what. So when you get to this question, again, there's a couple different ways you could do this, but if I'm looking at it, the inner function, maybe I would consider the inside function to be the 5x plus 2. And what did that go into? It went into 4 over x squared. So this went into the x, then was squared into the 4. Now, another idea would be you could say that maybe 5x plus 2 squared was the whole, inner function, and what did it go into? It went into 4 over x, and then it just takes that, looks the same. Both of these are correct. There's not one that's better than the other. It's just a couple different ways to look at how that might have been composed. When we get into calculus and we do something called the chain rule, it'll be really important for us to see what are these inner functions and how did they get constructed.